Hello, everyone, and welcome to our webinar How AI Reshaping Claims Management in Insurance. In this session, we will talk about generative AI and how it does create value for insurance sector. By the way, generative AI is a specialized stream of AI, and we shall discuss about it at length. About myself, my name is Hassan Shirwani. I hold a PhD degree in data science and have around 14 years of experience in this domain. Seeing both academia and industry, it's fascinating to see how industry has evolved in recent years. And AI, that used to be a hype word, is now becoming reality. Enough about me, let's talk about agenda. So first up, we would talk about Royal Cyber. I hope you all are familiar with the name of Royal Cyber. Nevertheless, I would introduce our organization. Then we will talk about generative AI and how it does affect an organization on enterprise level. Then we would talk about our case study. We have a solution created recently for our client, which is called Proclaim. We would give our demo and some of our learning from this experience. Finally, we would have Q&A session, so stay tuned. Royal Cyber is a leading IT consultancy with over 20 years of experience. We are a family of more than 2,000 around 10 countries. Most of our consultants are certified and well equipped with modern technology expertise. We take pride in our collaboration with technological partners such as Microsoft, Databricks, Snowflake, to name a few. So AI is not a new idea. We have all seen search engine recommendation systems and movies recommendation voice bot like Siri obeying our commands. However, many of us never anticipated that AI could reach a point where it could generate text for a specific use case. The struggles we faced in writing code as developers, or the countless hours spent searching on Google for the right solution were once common challenges. Yet, the technological landscape has shifted dramatically, and those tasks have become relics of the past. How has this become possible? The answer lies in groundbreaking advancement in deep learning and natural language processing. These technological leaps have paved the way for generative AI, a field that harnesses the power of algorithms to translate thoughts into visual representation or automate the creation of complex code. Thanks to these developments, we are now experiencing a future where imagination and innovation intervene, transforming the once unthinkable into everyday reality. Generative AI actually refers to a branch of artificial intelligence that focuses on creating models and algorithms capable of generating new original content such as images, text, music, and even videos, thanks to recent multi-model of GPT-4. Unlike traditional AI models that are trained to perform specific tasks, generative AI models aim to learn and mimic patterns from existing data to generate new unique outputs. Generative AI has a wide range of application. For instance, in computer vision, generative AI can generate realistic image, create variation of existing image, or even complete missing part of an image. In natural language processing, that is for text data, generative models can be used for language translation, text synthesis, or even to create conversational agents that produce human-like response. Beyond these examples, generative AI can perform art generation, document augmentation, and even generating synthetic medical image for research and diagnosis. It's powerful and creative tool that allows us to explore the boundary of what possible in computer vision. Moving forward, let's talk about some components of generative AI. First up, we have artificial intelligence. It is a broader discipline of machine learning to perform tasks that would typically require human intelligence. Machine learning is a subset of AI. It involves algorithm that allows computers to learn from data rather than being explicitly programmed to do so. Deep learning is another subset of machine learning which involves neural networks with three or more layers that can analyze various factors of a data set. Finally, we have generative AI, which is an advanced subset of AI and DL. It focuses on creating new and unique output. It goes beyond the scope of simply analyzing data to making new creation based on learned patterns. Let's talk about some of applications. In text generation, we all are familiar with ChatGPT. In image generation, we have stable diffusion models. In audio, that is our speech data like ASR, we have many models, but I'm giving just one example of Whisper. And by the way, we have used Whisper in our solution, so I'll get back to it. In video generation, we talk about image gen video. And again, in our case study, we would also have video data. There are other examples, of course. This is just a very basic example. Let's talk about some applications of text generation. So text generation involves using AI models to create human-like text based on input prompts. Models like GPT-4 use transformer architects. They are pre-trained on vast text dataset to learn grammar, context, and semantic. Given a prompt, they predict the next word or phrase based on patterns they have learned. Text generation is applied in content creation, chatbots, and code generation. Businesses can use it for crafting blog posts, automating customer support responses, and even generating code snippets. Strategic thinkers can harness it to quickly draft marketing copy or create personalized message for customers. Some of the examples of most commonly used models are GPT-4, which is coming from OpenAI, Llama, BERT from Google. Llama is open source, by the way, and CTRL from Salesforce. Again, this is not an exhaustive list of models, but just only a few examples. You might have your own favorite, so I have nothing against them. Let's talk about image applications now. So image generation involves using various deep learning models to create images that look real. Most interesting breakthrough in image processing world is GAN. So GANs consist of generator, which is like create an image, and a discriminator that determines real versus fake. They compete in a feedback loop with the generator getting better at producing images which discriminator can't distinct from the real ones. These models are used in art, design, and product visualization. And businesses can generate product mockups for advertising, create unique artwork for branding, or even generate faces for diverse marketing material. So audio generation involves AI creating music, sounds, or even human-like voices. Models like Wave can analyze and mimics audio wave forms. Text-to-speech models like Tectron 2 use input text to generate speech. In recent times, we have seen Whisper that has generated a lot of buzz. So in fact, as I mentioned earlier, we did apply for one of our use cases, and I'll explain that in later. Another interesting aspect is AI generated music that can be used in ads, videos, or background tracks. Brands can create catchy jingles or custom sound effects for marketing campaigns. Text-to-speech technology can automate voiceovers for ads or customer service interaction. Strategically, businesses can use AI-generated audio to enhance brand recognition and storytelling. Video generation involves AI creating video often by combining existing visuals or completing missing parts. Video generation is complex due to temporal nature of video. Some models use text description to generate scenes, while others predict missing frames or video. AI-generated video can be used in personalized message, dynamic ads, or even content marketing. Brands can craft unique video advertisement tailored to specific customer segments. Thoughtful application can lead to efficient video content creation that adopts to marketing trends. And then we have image gen video, cog video, stable diffusion. So all these models are actually one of few very popular examples, and one could plug and play. Moving forward, let's talk about how generative AI works. Actually, there are three layered concepts that I would like to talk about. Number one is discriminative versus generative modeling. Number two is generative adversarial networks, GANs. And number three is transformer-based models. I'll walk through one by one, and these are exhaustive concepts, so I don't expect that I would explain them or do justice with these concepts, but I just want to touch upon them so that we would know basics of generative AI and its working. First up is our discriminative versus generative model. So discriminative modeling is used to classify existing data points, that is images of cats and, for example, dogs into respective category. It mostly belongs to supervised machine learning tasks. In other words, most machine learning models are used to make prediction. Discriminative algorithms try to classify input data given some set of features and then predict a label or a class to which a certain data example belongs to. Talking about generative modeling, it tries to understand the dataset structure and generate similar examples. For example, creating a realistic image of guinea pig or a cat. It mostly belongs to unsupervised and semi-supervised machine learning tasks. In comparison to discriminative models, generative algorithms do the complete opposite. Instead of predicting a label given to some feature, they try to predict feature given a certain label. Discriminative algorithms care about the relationship between X and Y, whereas generative models care about how you get X. Let's talk about GANs. So GANs are a machine learning algorithm that put two neural networks, generator and discriminator, against each other, hence the adversarial part. The contest between the two neural networks takes the form of zero-sum game, where one agent's gain is another agent's loss. So what is a generator? It is a neural net whose job is to create fake input or fake samples from a random input vector that could be a list of mathematical variables, each of whose value is unknown. On other side, discriminator is a neural net whose job is to take a given sample and decide if it's fake sample from a generator or a real sample from the domain. So the discriminator is basically a binary classifier that returns probability, that is a number between 0 and 1. The closer the result is 0, the more likely the output to be fake, and vice versa. Numbers close to 1 to show a higher likelihood of prediction being real. So GANs were invented by Goodfellow and his colleagues back in 2014. Since then, there has been a lot of research and practical application making GANs, of course, the most popular generative AI model. There is a paper, Generative AI Adversarial Networks, and feel free to go for it. You may give it a go. I promise it is worth your time. Then comes Transformer. So these were described in 2017 paper from Google. Transformers are actually powerful deep neural networks that learn context and therefore meaning by tracking relationship in sequential data like the words in the sentences. The transformer is something that transforms one sequence into another. They are type of semi-supervised learning, meaning they are pre-trained in an unsupervised manner using a large unlabeled data set and then fine-tuned through supervised training to perform better. Some of the most well-known examples of transformers are GPT-3, or now we are calling 3.5 or even 4, and Lambda. Talking about some of the benefits. So one benefit is automated content production. It discusses how generative AI can create diverse content types, for example, articles, videos, images. It could highlight the reduction in reliance on human content generation, leading to consistent and scalable content production, which is very valuable for an organization. Then we have improved customer experience, which explains how AI-driven interactions, that is from chatbot, personalized recommendation, enhance customer engagement. It emphasizes the role of AI in understanding and responding to customer needs more efficiently. Then we have cost and time efficiency. It illustrates how automating processes would reduce operational cost and save significant time. It provides example where AI has streamlined workflow, leading to quicker times and reduced labor cost. Task automation is another important benefit for organization. It represents kind of a difficult or repetitive tasks that are efficiently managed by AI. For example, scheduling or data entry. It also discusses how automation allows human employees to focus on more strategic creative work. Data analysis highlight capability in handling large volumes of data for insights, trends, and predictive analytics. It explains how businesses can make more informed decisions based on AI-driven data analysis. Personalization actually show how AI tailors experience to individual users, enhancing user engagement and satisfaction. So some examples such as personalized marketing, customized content feeds, or product recommendation. Customization is another important flavor. It talks about the flexibility of AI in adapting to specific business needs and user preferences. Give examples of how businesses use AI to create customized solutions or products for their market. We, of course, have some limitations as well. So, number one is lack of word knowledge. Although we all know that ChatGPT can generate responses on a wide range of topics, however, it doesn't know about the word in the way humans do. It doesn't have access to real-time or updated information, and its responses are entirely based on pattern it has learned during its training, which includes data only up until its training cut-off time. Another issue is biases. ChatGPT can sometimes exhibit biases present in the data it was trained on. Despite efforts to minimize these biases during the fine-tuning process, they can still occasionally appear in models' output. Another problem is inappropriate or unsafe output. So we all know that efforts are made to prevent this problem. However, generative AI models may sometimes produce output that are inappropriate, offensive, unsafe, sometimes misogynic or racist. These are not intended behavior though, but they are actually side effects of models training process. So we always use this example, garbage in, garbage out. So if your data that your model is trained on is really garbage and full of some racist comments, then unfortunately your generative AI model would produce same results. Another problem is absence of common sense or deep understanding. So despite appearing to understand the text, generative AI models do not possess true understanding or, in fact, common sense reasoning in the way humans do. It makes prediction based on pattern it has seen in the data, which can sometimes lead to nonsensical or even incorrect responses. So you cannot actually rely for now on prediction generated from generative AI models. So finally, there is inability to fact check. And generative AI models do not have the capability to verify information or fact check its responses. It may produce outputs that seem plausible but are factually incorrect or somewhat misleading. Despite these all problems, I think generative AI are something that would generate a lot of value for organization that we have been showing in this webinar. And the next part is through our case study and our solution. we would actually explain you further about these positive sides. Let's talk about our solution now, Proclaim. So traditionally, manual processing of insurance claims, they required actually documents and their auto calls analysis, which is a time-consuming process and could also cause errors. Uh, Needs to mention they are not efficient. Another issue with the current problems is that when you evaluate these vehicle damage, then they only consider human judgment. So human intervention is at every level. What AI solution would do is that it would create an automated, optimized, and an efficient solution. And not only it is restricted to documents, it would also work for call records, for images, and even for video data. So if a customer has a complaint launched and he or she would like to fill a form and afterwards would attach an image or a video of their car damage, that would actually become part of as an attachment and would give us more information. In this solution, we would use AI solution to kind of automate the process and also extract key information. Advantage is that we got 80% better operational and cost efficient solution. Our accuracy improved a lot. So first round for our solution was rule-based approach, and afterwards we implemented classical machine learning approach. But adding large language models and generative AI solution, we actually achieved way better accuracy. And finally, upon our survey, we understood that customer satisfaction has increased from 35 to 55%. So that's definitely is a plus point. Our solution provide a solution that could be integrated both on mobile and web. It would analyze three key features. Number one is claim analyzer, number two is a damage analyzer, and number three is reporting. All of that is part of one uh, business intelligence system where you could monitor all of their performances. And in this solution, we would walk you through them. Just to understand a classical and a typical life cycle for claim management. First of all, an accident happens. Number two, an insured reports to event, and afterwards there is a consultant who would actually monitor the claim and provide you information. And number four step is that again a human assessor would check your car damages and creates kind of a report. And finally, the car goes to workshop for repairing. And as you can see that in almost all the stages, there is a human intervention. How organizations do solve this problem? First of all, there is a document that is uploaded into the system. After that, the document is analyzed. It would reach to a human. He or she would identify whether this is a claim, a journal inquiry, or a coverage question. Then it's kind of forward to a representative and damage inspector. But again, that person might be specialized, whether it's a claim or a coverage or whatever. Then this human on this end would actually process and forward this on our final endpoint. That's where a human would make the final decision. If I look at between this and this system, an AI solution has removed all human intervention. Only at the end, on our dashboard part, we have a human who would monitor and make a final call, a decision. Through this, not only we have reduced human effect, but also we have improved our efficiency. Imagine if a user who would apply for a damage claim would get a response after a week. Now it could be in less than a day. So that's definitely an improved solution, which in return cause to have a better customer satisfaction. Let's talk about solution. So first is our claim analyzer. In a claim analyzer, we might have a document, and if there is a document, then we use Azure Document Intelligence for labeling and all pre-processing tasks. On top of it, we use OpenAI GPT 3.5 for document solution. This is a pretty good model. I would come later where we need to implement more advanced solution if we want to do multi-model approach. But that is one way of looking at things. Second is our audio call. So whenever our audio call would come into it, we need to first transform into a transcription and afterwards apply our model. In this case, it's Whisper. Then we talk about damage analyzer. Suppose our user is sending this complaint or claim with an image or a video document. Now we need to use diffusion models because, or like GAN's model, as I explained earlier, because simpler models won't work over here. Then comes this Azure service like Azure Vision, and on top of it, GPT-4 Vision. Consider we are not using 3.5 because that is a multi-model approach, and we need to use updated version. To summarize all, suppose we have a customer over here, Bob, who would send a claim document. Once that document is sent, that we would use Azure Document Intelligence Service, and we have three different paths. If that is a document that is in text form, then it would go along this path. We would have our classification problem first up. It would classify what document it is, then it would summarize with our resolution, then it would create key extraction, and then finally to our Streamlit API. On second stage, if we are working with an image or video data, then we would follow this path. Our features are pretty much same. We would do summarization. We would also give this image captioning by inspection. Finally, if that is an audio, we would follow this path, and over here we would be using Whisper. Eventually, all of these solutions would combine on our web interface. So enough about explanation. Let's talk about our demo and let me walk you through that. So in this demo, we would talk about Proclaim, which is our solution. As mentioned earlier, we have three main components. Number one is Claim Analyzer, number two is Damage Analyzer, and number three is Smart Support. So let me start one by one. So in Claim Analyzer, we have a couple of features. So one is email analysis, second is demand letter analysis, then we have audio call analysis, and then we have claim form analysis. So these three are our text-based documents, and audio call, as name suggests, is audio. So I'll start with email analysis. We need to upload a file, and I load a file of David Johnson. So on this left-hand side, we would see this transcribed text form, and over here, this is processing. So it would take maybe a couple of seconds, and we would wait. So here we are. Results are out. Number one is detecting document. So this is an email, very obvious. But second is our category. So it's claim status update. Just note that the solution where we are using with our client, they are not aware of these documents. They come at random. So these two categorical information is really, really important and valuable for them. So next is, for example, if someone is sitting on analytics bench and would like to summarize what this email is about, here you have summarization, and you can see some key detail like insurance number and date. So you get pretty much idea about it. But if you would like to see what are some keywords, so we have that detail as well. So, for example, name of insured entity, insurer, that's our solution, claim number, location, and all those information up till policy number. So this information is more of a static nature. So policy number would remain the same with that email. However, if there is some query which is not directly mentioned in the document, like a regular expression, then we can also get it from here. So let me try this on. Is David a regular customer? And here you go. Yes, David is a regular customer of Insure AI, as mentioned, is policyholder under their health insurance policy. So with this information, you can get all other set of information that you would like to get. Coming to next feature, that is our demand letter analysis. So cycle is pretty same. So, so again, we have document type, that is demand letter. We have category, which is property damage. So this letter is about that. In summary, you can see the name of our employer, the amount, and overall content of this whole letter, and then key entities. So that's the idea. It would save some time at least of someone who's sitting on the bench. Then we have third case, which is our audio. There, let me take this one. I know I am somewhat killing the suspense because file name is loan insurance, but again, I can't emphasize more than that, a user at our end user level would not know all that information. And let me also play this audio for you.
Good afternoon. This is Sam. Thank you for calling Contuso. How may I help?
Hi there, my name's Mary. I'm currently living in Los Angeles, but I'm planning to move to Las Vegas and I would like to apply for a loan.
Okay, I see you're currently living in California. Let me make sure I understand you correctly. You'd like to apply for a loan even though you'll be moving soon. Is that right?
Yes, exactly. So I'm planning to relocate soon, but I would like to apply for the loan first so that I can purchase a new home once I move there.
And are
So here are results. So we just get some idea from hearing about this call, but some information is there. So if we want to fetch some information again, we can go there and write some information. So if I talk about what is intention behind this call, you can see where you want to apply through this loan. And one more query which I would like to know. So for example, someone is checking quality of this call. So they want to check if there is any rudeness in tone of our agent. And by agent, I don't mean AI agent, I mean human agent who is actually taking this call. No, there doesn't appear to be any rudeness. So It's something of a sentiment analysis. You could get a lot of information that is not directly mentioned and noted in the email. So, of course, I can go about and play around with this one, but let's move towards image, which is another important part. So, in image assessment, got some images. So, I would just close this image because I like white color cars. You go. So the detail is very interesting. You can look at car make and its model, its BMW and kidney grill and all this. Damage extent, which is again more like a summary. Then possible cause, which is very interesting, judging by the nature of damage and position. It may be nice that vehicle was driven at a relatively high speed and collided with a stationary object, such as pole or a tree. Interesting. Then we have this useful information about license plate. You can see the image only had a clarity on the sideway. So that's an excellent image processing model because it detected it pretty well. And then there is the airbag deployment date, mileage, other relevant information. So that is pretty comprehensive information actually about this image just going about. What happens is that with our claims form, mostly customers attach an image or a video file. The next is a video that I would choose this one. So you can see a pretty damaged car from front, but that's just an information. So let's see what our model is telling us. So as usual, it's pretty smart. It's telling about car make. So that's not very clear. Damage extent, front bumper damage, headlight damage. That's good. That's correct, I think. Very close to human. Possible cause and frontal collision possible with another vehicle or a stationary object. Yes, we have now. This information is actually very useful. License plate is not clear, so even a human would not understand that. Airbag deployment statement, there is no evidence, mileage, and other relevant information like paint, weather condition. That's very smart actually because it has picked something about the weather just by looking at it. And then the debris. That's very impressive actually. I'm not really sure if as a human I could fetch this much information out of it. So that's a very smart solution. And third one is our smart sports system. So if there is something that we would like to know in journal, like analytics team or content generation team, then they get actually from here. So consider it like a frequently asked scenario. If I ask, tell me about insurance policy, insurance policy is a contract. It's a very generalized term, right? Let's be specific to our domain. What is 3D policy? Insurance policy offered by company includes. That's good. That's a good way. And suppose I also have a query. I have had an accident. How can I make a claim? make a claim, you need to, it is important to report the accident. So, a pretty useful information if you are looking for frequently asked question, and I would say that they are pretty accurate here. So, I would stop demo here. We have some key learning from this demo, and let's talk about that. Through this project, we actually learned couple of key lessons, and we would like to share with you. Number one is our data-centric approach. So there are two famous approaches. One is model-centric and other is data-centric. Model-centric approach is that we fix our model, its parameter and its key components. In data-centric approach, it's mostly centered on data side because it's a data science domain. And over here, we have a very old saying, which is garbage in and garbage out. So if we have a bad data, then we cannot expect model to do any magic. So first point is to fix our data and to understand different patterns from data. A clean version should go over there. With unstructured data, such as images and text, it becomes more and more challenging. Second point is an end-to-end solution. So again, we are not model-centric, but we would like to see an end-to-end solution. So for example, we have different roles in this project. If there is a data engineer, he or she would actually work with their pipelines. If we have a data scientist, that would be working actually on models. And of course, there is a team for deployment. So model deployment would actually be all about observability if there are any things going wrong. Key concepts are such as model drift, data drift, or concept drift to evaluate if things are going fine. And third point is our performance validation. It's very important to see how model is actually performing. And by that, I don't mean mere accuracy or old methods. We all know that large language models are actually prone towards hallucination. So that could happen. A quick fix is either use RAG or fine tuning, but a cautionary notice is that they could be expensive. So then you need to understand the difference between your performance and your price. So if you are going to pay for a high cost, your performance might be actually better. Ideally, we would like to go for a scenario where we have a higher performance and lower cost. And finally, last but definitely not least, is regulatory compliance and ethical AI, which is often neglected but is very important. That data is secure and we are actually following all best practices of our data governance. So these are some of the key aspects that we have learned. And this project has actually not come to an end. This is an ongoing process. And hopefully we will come back to you with more learning and more understanding in future. For now, I would stop this one and we would take a Q&A. Thank you.